Okay. If you want to talk during this, please leave. I am not going to do well talking over voices at all. Problem number 3.
Yeah, I can do number 3. But we're not doing that today.
Okay. We've talked about this before. The question is, when you have to change it from degrees to DMS, you always multiply the decimal by what?
60.
60. So, start off, 66. Then I'm going to take the decimal, 0.08, multiply by 60. Quickly doing that in your head, you should have 4.8.
Yup.
So I take the whole number. That's my minute. Again, I only multiply the decimal. There's still a decimal, so I still got to multiply by 60.
48.
That's 48.
48 minutes.
No. 60 degrees, 4 minutes, 48 seconds.
Yay. That covers 4 too.
Number 4. What's the angle, Judah?
Number 4, 31.53 degrees.
Walk me through this. Are you on your phone for math? Michael, what do I do?
Times 53 by 31. Oh, 0.53 times 6.
Take the decimal, we multiply by 60. Did we get 31.8?
Yeah.
Only take the whole number, 31. Now what, Michael?
Oh, I have to write it down. I don't know. 0.8 times 60.
Take the decimal and multiply by 60. That equals 48. 31 degrees, 31 minutes, 48 seconds. That is what it is converted.
Yay.
Squadouche, is that right?
Yeah. 9, I think.
Number 9. Convert to radians.
Come on, guys.
63.46. What's my converter? Change something from degrees to radians, people.
Times pi over 180.
Times pi over 180. I need somebody to put that in a calculator to give me the answer. and I need someone to confirm that they're right.
1.1076.
What do you got?
1.1076.
Did someone confirm that's correct?
Yep.
Okay. Bada boom, bada bing, ain't no big thing.
No.
Okay, let's see if we read the directions correctly. Directions are: how is the new graph obtained? How does the new graph f of x obtained from g of x? Which means I start with this graph, and then I gotta figure out what they did to modify it to get to that graph.
So it's gonna be a vertical stretch because you're, oh wait. No, it's gonna be.
When I attack it at the very beginning at the amplitude. There's some number change, correct?
Yeah.
Therefore, I know it's vertical. Is 1/6 more or less than 1? So I call it a string.
It's gonna vertical.
5 1/6, right?
Indeed.
Okay. I got a number in front of the x. That means it's horizontal. Is that a shrink or a stretch, though?
Stretch.
Hmm?
Stretch.
Well, let's figure that out. Period equals 2 pi over b. In this case, it's 2 pi over 1, which is 2 pi. Period equals 2 pi over b. In this case, it's 2 pi over 4 over 5. Keep it, change it, flip it, 10 pi over 4, which is 2.5 pi. Is 2.5 pi bigger or smaller than 2 pi?
Bigger.
What's bigger mean? Stretch. I really don't have to do anything else.
5/3.
It's 5/4.
So it's A.
It's gotta be A.
Oh.
She gone.
13. Oh, 12's up there too.
Oh, I
Yeah.
skipped 12. I'll go back. I don't need to skip it, no. Do I? Okay, we'll do it. Alright. Did I write that right? 1.5 really doesn't matter. It says find the period. Does anybody know a formula for period? 2 pi over b. What's b? 8. Reduce 2 pi over 8. 5 over 4. That's it. 12. Since I accidentally missed it. What's the first thing you notice? It's a vertical stretch. This is one, has new amplitude, therefore it's vertical. Since it's bigger than one, it's a stretch. Now a sine wave looks like this. Negative sine wave looks like that. What axis is that reflected over?
X. Can it ever be reflected over the y-axis?
We have to severely modify our sine wave with a completely different setup and bring it in exponents. Bye bye, Miss American Pie. Drove my Chevy to the levee, but the levee was dry. Them good old boys were sitting and trying to do trig. Bye bye, Miss American Pie.
Why would they try to do tree down
Because it's a way to relax yourself. There's many Friday nights I sit in my hot tub at home with a nice Diet Pepsi doing trig proofs just for fun. Kind of like this morning I had to do my Wordle. People do Wordle for fun, I do trig proofs for fun.
I don't think he does it. I think he does, definitely doesn't drink Diet Pepsi. It's hot tub.
Change that 2 degrees. What's our converter? Divides by 180 over pi. Cross, 180, that divides equals 30 degrees. Amelia, was there a faster way of doing it?
No.
Wrong, yes.
Yes.
You could have looked at E in a circle, looked at 30 degrees, or at pi over 6, and it says 30 degrees right there.
Right.
As cool as the other side of your pillow. I'm believing I'm at 22.
Yep.
That one you kind of just gotta prove it.
Not only do it the pi, that's the thing.
Amelia, that stinks.
I'm gonna skip 22 for a second. Judah's gonna help me with it. Judah, please flip it on.
Okay.
I'll be right back to number 22.
I need to. Did I type it in? I have.
So I'm gonna look at 27. Okay. It says find sine A, cosine A. Now A is up in the top corner. There's two ways of doing it. One, I can reorient it so that A is on my corner closest to my origin. Which may be a little bit easier. Or I'm just gonna have to go back to old-fashioned SOHCAHTOA.
Sine equals y over r.
Sine equals y over r for the opposite
Y.
over the hypotenuse.
I thought that 24 would be y.
If the angle was the one we're talking about right here.
Oh.
Since we're talking about angle A, that's why I spin it 90 degrees so it's down here so we have the XY set up correctly.
Okay.
What's the definition of sine, Jacob?
Sine is opposite over adjacent.
Please tell me what's opposite. No, it's not.
No, that's
That's
tangent.
tangent.
And sine would be
X over r.
adjacent over hypotenuse.
Adjacent over hypotenuse, or x over r. All you have to do now is reduce it. Mason.
4 over 5 and 3 over 5.
Yeah, Mason.
Those are your answers. Do you have my thing up? Do you have my thing up?
Yeah, I got you know.
Okay, I need you to put it on my screen. Put it on my screen.
Oh, okay. How is that happen? This is just magic.
Please, we're doing number 22. I'm not writing it on the board because then I'd have to write it on this sheet and then that would be ruined. So. Okay, so here's my graph. All I did is open up decimals and I typed in the graph. It asked me to find the zeros. Can you click on the screen so this is gone?
Yeah.
Okay, zeros are where y equals 0. So can you click on each of the zeros in this graph? Okay, click on that. Good. Find another one. 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 Okay, no, we don't have to blow out. Let's just stay where we're at. That's fine. Now you lost my zeros.
Listen, they're coming back, slowly but surely. You just keep talking. Make this less
Okay.
helpful.
Now, do you guys have any questions how I found the zeros? Now, here's the little trick. It says interval negative 2 pi to 2 pi, which means it has to be between negative 2 pi and 2 pi. What number's 2 pi about?
6.
6. Let's just do 6. So we only can count the intervals from 6 to negative 6. So turn this one off because that's outside the number negative 6. Okay, so now there's my answer.
All 4 of them?
All 4 of them. Now, if you look at your answer, it actually only wrote 2 and put a special symbol in front of those 2. What is that special symbol?
There's a positive and a negative.
A plus minus. So it's saying pi over 2, plus pi over 2, and minus pi over 2 by just saying plus minus pi over 2. That's it. 22, you do that. 23, exact same concept. Decimals, click on the zeros. If it's inside the 6, more specifically 6.28, it's good. If it's outside, we can't use it.
Right on. I've had no problem.
Thank you, Judah.
Go. 30.
30?
Yeah, 30.
Judah, you're gonna do 30 for the class.
Oh, geez.
All you have to do is type that equation into Desmos.
Right on. Whoa. You know which one it is.
What do you do now, Judah?
Oh, you're just trying to match up points.
Yeah, you just match.
It's like a matching game. Yeah.
There you go.
That's there. Big thing is there.
I said you guys can cross out 29, correct?
Yes.
Okay.
What, really?
Oh yeah, the amplitude, 3 period, pi over 6.14. Yeah, that's hard.
That page should be done. Okay.
Then we go straight to 40.
That really surprises me. Nobody had any questions on problems number 32 through 35.
Oh,
Because you
I
made
forgot to
us
ask
know.
about 30.
What'd you say?
You say, yeah, you told us about now.
Oh, let's do it anyways. It's gonna be
Oh
fun.
my golly.
Really?
Desmos.
You're gonna go that way? Desmos, good. Let's do number 33. 33 on Desmos. Type it in, Judah.
Okay. Alright.
I'm just saying.
It doesn't mean we can't learn it. Jeez, Amelia, we're just
I'm just making
whining.
sure.
God.
Okay. Michael, is that equation periodic?
Yeah.
He's
Wait.
right.
Yeah.
It's a repeating pattern. Michael, is that equation sinusoidal?
No.
No,
No, it's not, because
it's not the same every time.
it's the high and the low changes every time. Now I ask you to find the period on this.
So like,
So the easiest way to find the period is to find one point, and then the matching point when it starts all over. So Judah, right here, click on the point at the top right here. I like this one easier. Okay, click on it, you got it?
yep.
Okay, click on the point right here where the pattern starts over. Okay, good.
Again over here.
Yeah, we can do another one, but let's figure it out. X is at 6.37. It starts at 0.089. This minus this is approximately what? 6.2, 6.3, which is, as Calvin wisely noticed,
2 pi.
it's 2 pi. The period is 2 pi. How do you do it? You just measure the point, and then the point on the second time that this thing goes through. That's it.
That makes sense.
Yeah, it does, Michael.
I know if I said it.
Number 40? All right. Judy, you want to type in number 40?
Oh, heavens, yes. You wanna read it to me? Jeez.
Oh, x of x equals 4 sine 3x. 4
Oh my
sine.
gosh, stop. Jeez.
I guess it's
Equals
really
4 sine 3x
minus
minus
2 cosine. Oh wait, negative. Oh wait, no, you got it. Oh yeah, 2 cosine 3x.
That was pretty good video.
All right. Here we go. They typed it in. Find the amplitude. What's the amplitude?
1 point. Is
no.
it, I can't read that number.
It's 4.7
4.472, right?
2, yes.
It's the height.
Yeah.
Gee, why not?
Are you guys done? Continue your
No.
conversation in the hallway. I don't care.
No, get out of here.
You don't have to be here.
Shut your.
I'm not forcing you. Find B. Well, on a sinusoidal equation, where is B usually found? By the x. Well, let's look by the x. What number's by the x?
3 on both of them.
Well, then what do you think B is?
3.
So if you look at the answer, look for 4.47 and B equaling 3.
C.
And we don't care about the other piece because there's only one that has those two answers correct.
Yeah, it's true.
So we're done.
Just found it.
I actually did those and then I broke mine.
Now, I told some smart kids in the back of the room there's even a faster way of doing it.
Just look at the equation.
Your height, yeah, but always a little bit. I don't talk over voices. Let's plan a detention on Thursday this week after school also. Interrupt me one more time. I couldn't do any work yesterday because you guys wouldn't get on focus. And today you continue to choose to talk. I'll see you Thursday after school, or you will be at Thursday after school for an hour. Any questions? Good. Again, if you do it the fast way, your amplitude is going to be the number a little bit bigger than the bigger of the two amplitudes. The bigger number is 4, so if you look at all your possible answers, you have to look for an amplitude that's a little bit bigger than 4. You look at B, you find the 3 right away, you don't even have to graph it.
Nice.
Let's see how this goes. This was problem number, let's do 41. Logan, number 41. I want you to look at the graph. I want you to look at all the possible answers and which amplitude makes the most sense out of all of them.
It'd be, would it be 2?
Nope.
D.
Mackenzie, help him out. On number 41, what's the amplitude? 3.61. How does she know that? Because 3 is the bigger of the two numbers. All the answers only has one a little bit bigger than 3. 3.61. There's only one answer possible at this point. But Judah was overachieving, and he double checked to make sure the B was right. What's the B in that one?
3.14 because it's pi.
Pi.
next to that.
Good job.
$44. $44 not out there, is it? I'm just making that up, correct?
Yeah, 44 we kind of need to do that for sure.
Did he do it?
I think so, right? Oh yeah.
Brooke, how C can't relate to cosine?
It's opposite. It's the opposite. You flip it, just flip it around.
44 needs to be feet. Okay. This one's a much more challenging problem. Good thing I know my trig identities. Triangle, theta. Where do I put the 3 on my triangle? Where do I put my 4? How do I find my x? Pythagorean theorem. 4 squared equals 3 squared plus x squared. 16 equals 9 plus x squared. Minus 9, minus 9. 7 equals x squared. Square root of. Square root of 7 equals x. What's the definition of cosine? X over the radius, or hypotenuse. There it is. I have to build the triangle, find the third side, and apply the definition. Okay, 54. Triangle. The distance from the base is 48 feet. Your angle is 62 degrees. Find the height. It'd be really cool if I had a trig function that would apply to a theta, an x, and a y. Do we know any? Wow, Michael.
I don't know anything else. I don't remember.
Keegan.
Tangent.
Tangent. I know this is the first time I surprised you guys with this type of problem.
Yeah.
Now what? Multiply both sides by 48. Someone type that in the calculator and I need someone to confirm the correct.
Let's give this guy a second.
I got 90.27.
Can anyone confirm that he's right?
No, I got 68.8. That's not enough.
Sure it's 90.
What'd you get?
60 is 90.
I got
Brooke and Kelvin confirm that's 90.27.
Yeah, 90.
Beat.
I got 90.27.
All right, then I got further confirmation that you did it right.
Wait, there's no 90. You rounded to 90.
Keegan, you're losing your patience as fast as I am.
He's my cousin, so.
I get it.
feel bad. Who's his best friend?
Who's and best friend? Cool.
No.
Whoa.
Oh, yeah, so you're the king.
Jake. This is like a clock hand. For example, if you have a clock hand right now, it should be pointing, let's just say it's halfway between the 10 and 11. 12 hours from now, will be a complete circle, where we'll end up. Exact same spot. What if I went 12 hours last night? Where would it be on the clock? Same spot. If it's- Okay? So, keep that clock hand in mind. If I'm looking for coterminals, I want to find other places where we'll stop at 5 degrees.
Okay.
Well, how many degrees are there in a circle?
360.
So if I take 5 degrees and I spin a whole circle on it, where's it gonna end up? So 365 degrees is the exact same spot as 5 degrees, isn't it?
Yeah.
Okay. So what I do? I take the circle and I add it.
Oh.
5 degrees. I'm winding my clock backwards.
Oh.
How far do I have to wind it backwards to get back to 5 degrees?
355.
Why? Worry about this.
Questions? Fifty-six is the exact same concept, but we're gonna deal with radians. So please change your mindset to how do radians work and how many radians there are in a complete circle. Can anybody tell me how many radians it takes to do a full circle? 2 pi. So I'm going to add 2 pi, and I'm going to subtract 2 pi. So 9 pi over 5 plus 2 pi. Some people may mistakenly say that's 11 pi, but they will be wrong because of why. Have to have the same denominator. They both have to have 5 as a denominator.
And the denominator, that one's 1.
So I'm going to multiply the top and the bottom by 5.
So that's like 10 pi over 5.
So
19 pi over 5.
Now, I've already calculated what this is, what 2 pi is as the fraction, so I'm not going to do it a second time. So I did the plus part. Now I'm going to do the minus part. That's all she wrote.
That wasn't 59, was it?
56. Good catch. And I thought you didn't pay attention most of the time. My bad.
What?
Okay. Got a triangle. This is my x, negative square root of 11, my y, negative square root of 6. How do I find the third piece of my triangle? Pythagorean theorem.
Square roots.
Yeah.
So it's 11.6.
Why?
That was really squeaky.
Oh, that was still a good marker.
No, it was really squeaky. Logan said, the cool thing about this is all it does is get rid of the square roots. What's the the definition of cosecant theta?
The opposite of cosine.
Okay, what's cosine?
X over R should be R over X.
R over X. Okay, got a problem with my radical sign.
What's wrong with it?
Gotta bump it. Bump it up.
It's in the denominator, so we're gonna bump it up. Bump that radical up.
Keep that base.
Keep that base.
That's the best song
Michael, you only
What's 17 times 11?
187.
Pull the negative to the front. Keegan calculated at 187.
You want to answer?
D.
It's D. What's next?
I see 64.
Senior, you did 58 with us yesterday, and it was C. The answer key says it's C as well.
Then I think 187 was calculated wrong.
Oh, yeah, I remember.
Hold it.
Sorry.
Hold up. Wait.
Somehow we the procedure's right, the number calculation's wrong.
They calculated it wrong yesterday.
I feel like it's that number, right?
Well, 11 times 11 is 121.
Plus 11 times
58
6.
should be
66.
C is 102, correct?
Makes sense.
This should be 187.
Yeah, definitely. What was it yesterday?
We just calculated the 102 and the 187 wrong. We did all the steps right.
No, because they have a 6 on the bottom.
Dang.
See? So I'm guessing we just used the wrong radical.
50.
58.
What's the radical?
Cosecant south. Oh,
It's
we found
X.
cosine, didn't we? We didn't find sine.
Yeah.
That. Thank you for catching that.
No, we found sine, not cosine, because sine is
Cosecant should have been the
y.
opposite of sine, but we used the opposite of cosine on that. That's why it should be -6 instead of 17. And when we do that,
To use that, do 6.
6, 6,
Guys, leave the work.
02,
Just gotta change the
and 6. All the math was correct. We just used the wrong side. Great catch on that, Brooke. Thank you.
Good catch.
Or London, or Mackenzie. One of you guys did it. 64. Okay, where's 64?
And 990.
Okay. Look at unit circle. Tell me where 990 degrees is on unit circle.
There isn't one.
There isn't one. What's the maximum it goes up to?
330.
360. You guys understand the analysis?
360.
Remember when we took 5 degrees and we spun the clock hand to end up back at 5 degrees?
Oh, it's the
Yeah.
co-terminal thing, so you just
So-
you multiply 330 by 3, so you multiply the thing that's...
We're not multiplying. So let's unwind 990.
Unwind.
How many degrees are there in a circle?
360.
Oh.
Is 630 on our unit circle?
No.
Unwind it another circle. Is 270 on my circle?
Yeah.
What's tangent at 270?
Isn't it like undefined or something? Yeah, undefined.
Undefined.
Jeez. I really don't know what that was. subtract by 360 twice.
Until we're back on the unit circle.
So we're back on the answer. Oh, I'm with you. Yeah,
72. Arc sign is a fancy way of saying this. How do you do this?
Inverse.
Look at your unit circle, and tell me where sine equals 1/2. What angle is that?
Well, isn't it 2?
Make it 30 and then you transfer it to radians to get the answer, which would be pi over 6.
hold on. Where's 30?
30 degrees.
So if you looked at 30 degrees and you looked in the y column, it should say 1/2.
But y could also be 100.
Now, without Amelia saying anything, I'm gonna ask this people right here to find the other place where sine equals 1/2. In radians.
Yeah. In radians, it'd be
You can narrow it down by realizing sine is positive. There's only 2 places sine is positive on your thing. There, or up. Okay.
So like,
Can I have a
152 again?
She pull a Sherry and then you walk home and say, yeah.
Which is also 5 pi over 6?
Let me stop it.